Okay, this problem says at a particular instant, a 1 kg particle's position is r is 2I 4j minus 4j plus 6k meters. Its velocity is that, and the force on it is that. What is the angular momentum of the particle about the origin? So, I mean, we are just going to do definitions here. This is just to make sure that you understand the definitions. Here's the definition of angular momentum. It's this cross product, r cross linear momentum, okay? And that's equal to r cross m times velocity equal to m times r cross velocity. R is 2I minus 4j plus 6k crossed minus I plus j, oops, all right, so we are doing this cross product. So let me remind you of the definition of a cross product. Okay, so here is how you remember it. See, the x component does not have the x component of the vectors. And the y component starts off with z dx minus ax dz plus the k component steps ax dy. Okay. So that's the definition of cross product, and that's what we'll use. Alright, so this is equal to 1 kg. Well, I mean, we don't have to multiply the 1. We'll write down the final units. So this is the x component is ay bz minus 4 and then minus of az by minus 24 plus the y component is az bx, so that's minus 6 minus ay ax bz minus 2 plus the kth component is ax by 2 times 4 8 minus ay bx. Okay, so that's what that works out to. Okay, so we can clean this up. So L, the angular momentum, is minus 28I minus 8j plus 4k. And can anybody help me out with the units? Very good. Kilograms meter square over seconds. Okay. There's the kilogram and then the meter square over second. Okay, part B, they ask you the torque. Torque is R cross F, so we are finding that cross product. And R is minus I plus, oops, R is 2I minus 4j plus 6k. And F is 10I plus 15j. and the kth component is of course 0. Okay. Now, since there's only 2 components here, it will be easier to do it like this. You guys just have to remember. All right. Okay, so you guys just have to remember I cross j is k, j cross k is I, and so on. Okay? And you guys remember, what is I cross I? What is I cross I? Any vector crossed with itself is 0, and so on. Okay? And one other thing you have to remember, j cross I is what? It's minus k. Remember, cross product is anti-commutative. A cross B is C, B cross A is minus C. So these are all the properties that are being used. Okay, so these 3 properties. All right, so torque is, again, I'm going to just rewrite this. Okay, here I'm going to, rather than using this, I'm using this stuff, okay? And here's why. I cross I is 0, I cross j is k, and so 2 times 15 is 30k. That's the first term. I'm just distributing it. J cross minus j cross I is plus k. So that's 40 plus 40k. And then j cross j is 0. And then, oops, k cross I is minus j. So that's minus 60j. And k cross j is k cross, whoa, what happened? K cross I is minus j. No, k cross I is plus j. Sorry, k cross I is plus j. So what you're doing is you're going in a circle. I, j, k. I cross j is k, k cross I is j, and so on. Okay. And then k cross j is minus I. So, and that is minus 90i. Alright, so minus 90i plus 60j plus 70k. And what are the units for torque? Newton meter. Okay. I just wanted to show you another way. You can always go back to your default method of calculating the cross product. All right. Part C. What is the time rate of change of the particle's angular momentum at this instant? So part C is just asking you this question. Okay. That's all. The angular momentum is the time rate of change of angular momentum. Okay. So at this instant, you calculated the angular momentum. There's the angular momentum. You calculated the torque. And this guy is changing at this rate. So if you wanted to, so for instance, if you wanted to find the angular momentum at delta t later, so L plus dl would be L plus dl would be tau times dt. Okay, so that's what that equation is telling you. Yeah. So the angular momentum, this guy is that fella. And if you wanted to find what was the angular momentum a tenth of a second later, take that vector and add this vector to it. And you get the angular momentum a tenth of a second later or whatever. Okay. All right.